We'll start with this first question that we have here, which says that we should reduce the following trigonometric expressions. So in order for us to be able to reduce this, we need our cast diagram. Yeah, so this is going to be equals to sine of, so we know that 163 degrees is found here in the second quadrant. So this is going to be 180 degrees minus 17 degrees here, divided by cos of, and then we know that 197 degrees is found here in the third quadrant. So this is going to be 180 degrees plus 17 degrees plus tan of 17 degrees plus, and then we have cos of 180 degrees minus theta, which is here in the second quadrant, and tan in the second quadrant, cos in the second quadrant is negative. So here I'm going to have negative cos theta times 180 plus theta is found here in the third quadrant, where tan is positive. So this is going to be equals to 180 degrees minus 17 degrees is here in the second quadrant, where sine is positive. So this will be positive. So this will be sine of 17 degrees. And then 180 degrees plus 17 is here in the third quadrant, where cos is negative, plus tan of 17 degrees minus cos theta times, so tan theta is the same as sine theta divided by cos theta, and this is going to be equals to negative tan of 17 degrees plus tan of 17 degrees minus this cos theta is going to cancel this cos theta, and this tan is going to cancel this tan, so that the answer here is going to be negative sine theta. And then now we move to question number 2, which says that if f is equals to tan of 67 degrees, express the following in terms of f. So what I'm given here is this expression, and I have to express it in terms of f. And in order for me to be able to find an answer to this, I have to have my cast diagram, of course. Okay, so this is going to be equals to sine of, so 293 is found in the fourth quadrant, and in the fourth quadrant we have 360 degrees minus an angle. So the angle which I have to minus from 360 in order for me to get 293, it has to be 67 divided by, so here I have an angle that is greater than 360. So what I'm going to do is I'm going to minus it by 360. So when I say 427 minus 360, what I get is 67. Plus, I have tan of a negative angle, and negative angles are basically found in the fourth quadrant. And in the fourth quadrant, tan is negative, so this is going to be negative tan 67 degrees. And then I'm adding by tan of 1147, so I can minus 360 from 1147 till I get an answer that is, till I get an angle that is less than 360. So when I do that, the angle that I get is 67. So here I'm going to have tan of 67 degrees, and this is going to be equals to, so I know now that in the fourth quadrant, sine is negative. So this is going to be sine of 67 degrees divided by cos of 67 degrees. And then this tan here is going to cancel this tan. And this is going to be equals to negative tan of 67 degrees, which is going to be equals to, so we were told that f is equals to tan of 67 degrees. This is going to be equals to negative f. Write each of the following in terms of sine of 40 degrees. So in order for me to evaluate all these trigonometric functions, in order for me to write them in terms of sine of 40 degrees, I'm going to need a cast diagram. Okay, so now that I have my cos diagram, I know that cos of 50 degrees is the same as cos of 90 degrees minus 40 degrees, which is equals to, I know that cos of 90 degrees minus 40 degrees is the same as sine of 40 degrees. And then now we move on to the second one, which is sine of 320 degrees. I know that 320 degrees can be found in the fourth quadrant. So this is going to be equals to sine of 360 degrees minus 40 degrees. And sine in the fourth quadrant is negative. So this is going to be negative sine of 40 degrees. And then now we move to the third question, which says that we should find cos of 230 degrees. So we know that 230 degrees can be found here in the third quadrant. So this is going to be cos of 180 degrees plus 50 degrees, which is going to be equals to, now we know that in the third quadrant cos is negative, so this is going to be negative cos 50 degrees. And as we have seen here in question number 1, cos of 50 degrees is equals to sine of 40 degrees, so this will be negative sine of 40 degrees. And then we move on to the last question now, which is cos of 130 degrees. We know that 130 degrees can be found here in the first quadrant. So this will be cos of 180 degrees minus 50 degrees. And cos in this quadrant is negative. So this will be negative cos of 50 degrees, which will be equals to negative sine of 40 degrees. And then now we move on to question number 5, which says that we should express the following in terms of t, if t is equals to sine of theta. So this is going to be equals to cos of, so whenever you are given something like this, so like let's say a trigonometric angle, so like let's say a trigonometric function, let's say tan of let's say alpha minus an angle, let's say 27 degrees. In order for you to be able to use the cos diagram to reduce this sort of a function, so like let's say for instance, let me not put 27 degrees here, but then instead let me put 270 degrees. And then in order for you to be able to use the cos diagram by basically reducing this tan function here, what you can do is you can say tan of, and then you can factor out a negative 1 here on this angle, so that I'm going to have negative 1 times 270 degrees minus alpha. So that now I have 270 degrees minus alpha, which I can use to basically reduce by using the cos diagram. Right? So this is what like you would do basically at all times when you're given something like this. So here, when we go back to this question here, what we have now here is cos of theta minus 90 degrees. So I'm going to factor out a negative 1, so that it is 90 degrees minus theta times cos of, and then at all times when you are given something that is greater than, an angle that is greater than 360 degrees, here inside of this thing, you can minus it by 360 until it is less than 360. So here what you can do here is you can say 720, you can say 720 minus 360, which is 360. So I'm going to have 360 degrees here plus theta. And then here I'm going to do the same thing of factoring out a negative 1, so that I get 360 degrees minus theta, all divided by, no, this line is not beautiful, all divided by sine squared of 360 degrees plus theta. So I can rewrite this theta plus 360 degrees as 360 degrees plus theta times cos of 90 degrees plus theta here. And this is going to be equals to, so before you use a cos diagram to evaluate this sort of a thing, what you do first here is you ask yourself, so I have a negative angle and the angle I have is 90 degrees minus theta. So you ask yourself, what is cos of a negative angle? So we know that when we have a cos diagram where here is 360 degrees minus theta or negative theta, cos of any negative angle is equals to cos of that particular angle. So here I'm going to have cos of 90 plus theta times cos of 360 degrees plus theta. And tan of a negative angle is negative tan of that particular angle divided by sine squared of 360 degrees plus theta times cos of 90 degrees plus theta. So now I can draw my cast diagram in order for me to be able to evaluate or to reduce these angles. And by basically looking at this cast diagram here, so we know that cos of 90 degrees plus theta is the same as negative sine of theta multiplied by, and we know that cos of 360 degrees plus theta can be found here in the first quadrant. This is because here is 0 degrees, and then 90, and then 180, and then 270, and then 360 here. So here, the first quadrant can also be 360 plus theta. And in the first quadrant, cos is positive, so I'm going to have cos of theta here times 360 degrees minus theta is found here in the fourth quadrant, and tan is negative here, so I'm going to have negative times negative tan of theta divided by 360 degrees plus theta is found in the first quadrant, so I'm going to have sine squared theta here times cos of 90 degrees plus theta is the same as negative sine of theta, so this one will cancel this one, and then what I'm going to have now is cos theta times, so this negative and this negative will cancel each other, and tan of theta is sine of theta divided by divided by cos of theta, all divided by sine square of theta. So this cos theta will cancel this cos theta, and what I'm going to have now is sine of theta divided by sine square theta, which is going to be equals to 1 divided by sine theta, and they said that t is equals to sine theta, so this here, so this is going to be equals to 1 divided by t. And then now we move on to question number 6, which says that we should prove that the following identity is true. So what I'm going to do here is I'm going to take the left hand side, which is sine of 180 degrees plus a times tan of 360 degrees plus a times cos of a, all divided by cos of 90 degrees minus a. So we know that this is going to be equals to, we know that in order for us to know what the sine of 180 degrees plus a is, what the tan of 360 degrees plus a is, we have to draw our cast diagram. So I'm going to draw my cast diagram now here. And now looking at this now, sine of 180 degrees plus c can be found here in the fourth quadrant. And according to this cast diagram, in the third quadrant, sine is negative. So what I'm going to have here is negative sine of a. Tan of 360 degrees plus a can be found here in the first quadrant, because remember, when we move from here it's 0 degrees, here it's 90 degrees, here is 180 degrees, and then here is 270 degrees, and then we come back here, we cause a revolution, which is 360 degrees. So I can also say that the first quadrant is this 360 degrees plus theta. And in the first quadrant, tan is positive, so I'm going to get tan of a here times cos of a divided by, I know that cos of 90 degrees minus a is the same as negative sine of a. So now what I'm going to have here is this is going to be equals to this negative sine of a is going to cancel this sine of a, and I'm going to remain with tan of a times cos of a, which is going to be equals to, I know that tan of a is the same as sine of a divided by cos of a, and then I'm going to multiply by this cos of a here. So this cos of a is going to cancel this cos of a, so that I get sine of a. So therefore, the left hand side is equals to the right hand side. We have to show that sine of a plus b times sine of a minus b is equals to sine square a minus sine square b. So I'm going to take my left hand side, which is sine of a plus b times sine of a minus b. And what I can do now is I can expand these by using the compound angle identities. So I know that this is going to be equals to sine of a plus b is the same as sine of a times cos of b plus sine of b times cos of a. And sine of a minus b is the same as sine of a times cos of b minus sine of b times cos of a. So as you can see now, I have this part here and also this other part. And this part is the same as this one. And this one is the same as this one. So what I have now here is the difference of two squares. So what I'm going to do is I'm going to multiply this one with this one so that I get sine square a times cos square b. And then I'm going to multiply this one and this one so that I get minus sine square of b times cos square of a. And then now I'm going to continue here. So we know that according to this trigonometric identity, which says that sine square of x plus cos square of x, it says that this is equals to 1. Right? So it basically means that sine square of x is equals to 1 minus cos square of x, and that cos square of x is equals to 1 minus sine square of x. Do not worry, there's no need for you to remember or to memorize these formulas because you'll be given them at the back of your question paper. So according to these trig identities, what I'm going to have here is sine of sine square a times 1 minus sine square b minus sine square b times 1 minus sine square a, so that this is going to be equals to sine square a minus sine square a times sine square b. So I multiply this one and this one and this one and this one, minus sine square b plus sine square b times sine square a. So this part here is the same as this one. So they're going to cancel each other so that this is going to be equals to sine square a minus sine square b. So therefore, the left hand side is equals to the right hand side. Find the exact value of sine of 75 degrees without using a calculator. So whenever you get this sort of questions, what you should do is you should use special angles. So we know that our special angles are 30 degrees, 45 degrees, and 60 degrees. So what you can do is you can write this 75 degrees here as a sum or difference of these special angles, and then you can use these compound angle identities to find the exact value. So here we have sine of 75 degrees, and we know that 30 degrees plus 45 degrees is 75 degrees. So this will be sine of 30 degrees plus 45 degrees, which is going to be equals to find the answer to this question, to sine of 30 degrees plus 45 degrees, we can use this last compound angle identity here, which is going to give us sine of 30 degrees times cos of 45 degrees plus cos of 30 degrees times sine of 45 degrees. So 30 and 45 degrees are both special angles. So I can press my calculator. Sine of 30 is 1/2 times cos of 45 is 1 divided by √2 plus cos of 30 is √3 divided by 2. And then sine of 45 is 1 divided by √2. So this is going to be equals to 1 divided by 2 times √2 plus root 3 divided by 2 times root 2, which is going to be equals to 1 plus root 3 divided by 2 times root 2. Of course, if you don't like this answer to be like this, you can go ahead and rationalize it. And then we move on to question number 9, which says that complete the compound angle identity for each of the following. So for the first one, we have cos of x plus y. And where I have where I have an addition of two angles and I have cos, I'm going to use this compound angle identity. And this is going to be equals to cos of x times cos of y minus sine of x times sine of y. And then this one here, and then for this one here, I'm going to use this compound angle identity where my alpha will be equals to x and my beta will be equals to 8 of y. And this is going to be equals to sine of alpha, which is x, times cos of beta, which is 8y, minus cos of alpha, which is x, times sine of beta, which is 8y. And then this one here, we know that cos of 2c is the same as cos of c plus c. So this is going to be equals to, I'm going to use this compound angle identity, this one here, and according to this compound angle identity, this one is going to be cos of c times cos of c minus sine of c times sine of c. And this is going to be equals to cos square of c minus sine square of c. And then we move on to the last question. So this one is the same as cos of d plus d, which is going to be equals to cos of d times cos of d minus sine of d times sine of d, which is going to be equals to, this is going to be equals to, let me erase this one here. This is going to be equals to cos square of d minus sine square of d. Use compound angle identities to simplify each expression to a single term. So for the first question here, we have cos of 23 degrees times cos of 22 degrees. So I'm multiplying a cos and a cos. And I know that the two compound angle identities where I multiply a cos and a cos are these two, and I minus by a sine multiplied by a sine. Why minus by a sine multiplied by a sine is this compound angle identity here, and where now my alpha will be equals to 23 degrees and my beta will be equals to 22 degrees. So this will be equals to cos of 22 plus 23, which is 45, which is 45 degrees, which is going to be equals to, and we know that 45 degrees is a special angle, so I can go ahead and press my calculator, and for cos of 45 degrees, I get 1 divided by root 2. And then we move on to the second question. The second question, we have 1 minus, let me do this, let me erase this part here. The second question, we have 1 minus 2 sine 45 degrees times cos of 45 degrees. So this part here, I can simplify it by using this trigonometry, this double angle identity here. So this is going to be 1 minus sine of 2 times 45 degrees, which is going to be equals to 1 minus sine of 90 degrees, which is going to be equals to sine of 90. We know that it's 1. So this is going to be 1 minus 1, which is equals to 0. So this will be equals to 0 here. And then we move on to question C, number C. And number C, we have sine of 18 degrees times cos of 19 degrees. So I am multiplying a cos and a sine. And I know that where I multiply a cos and a sine are these two compound angle identities. But then I'm aiding by the multiplication of a sine and a cos. So I'm going to use this compound angle identity. So this is going to be equals to, where now my alpha will be equals to 18 degrees and my beta will be equals to 19 degrees. And I'm going to have cos of, this is 19 here, not 119. So I'm going to have cos, so I'm going to have sine of alpha, which is 18 degrees, plus beta, which is 19 degrees. this is 18 here, not 180. And this is going to be equals to 18 plus 19 is 37. This is going to be sine of 37 degrees. And then we move on to question number D. In question number D, we have 2 times cos squared of A minus 1. So we're going to use this double angle identity. So this is going to be cos of 2A. And then we move on to question number E. I'm multiplying a cos and a cos. And I know that when I multiply a cos and a cos, it's going to be one of these compound angle identities. But then I'm adding by the multiplication of a sine and a sine. So where I am adding is this one here. So my alpha will be equals to 81 degrees and my beta will be equals to 11 degrees. And this is going to be equals to cos of 81 degrees minus 11 degrees, which is going to be equals to, so I can erase this part here. 81 minus 11 is 70. So this is going to be cos of 70 degrees. So my answer here is going to be cos of 70 degrees. And then we'll move on to this question here. For this question, I'm going to use this first double angle identity here. So that this is going to be sine of 2 times 12 degrees, which is going to be equals to sine of 24 degrees. And then we'll move on to this last question here, which is the same as cos square of 15 degrees minus sine square of 15 degrees, which is going to be equals to, I can use this last compound angle identity so that this is cos of 2 times 15 degrees, which is equals to cos of 30 degrees. And 30 degrees is a special angle. So this is going to be equals to, I can press my calculator, cos of 30 is root 3 divided by 2. So this will be root 3 divided by 2. And then now we come to question 11. Question 11 says that prove the following identities. So for the first one, we have cos of A plus A. And we have to prove that cos of A plus A is basically equals to this. So we basically have to prove this double angle identity. So we know that this is going to be equals to, we are going to use this compound angle identity here. We know that this is going to be equals to cos of A times cos of A minus sine of A times sine of A. This is because our alpha will be equals to A and our beta will also be equals to A. So when we use this double angle identity, this is what we are going to get. And this is going to be equals to cos square A minus sine square A. But then what they are looking for here is 1 minus 2 sine square of A. So we know that sine square of A plus cos square of A is equals to 1. So I can make cos square of A the subject of the formula here, so that I get cos square of A is equals to 1 minus sine square of A. And now where I see cos square of A, I'm going to write this. So this is going to be equals to 1 minus sine square of A minus sine square of A. And this is going to be equals to 1 minus 2 sine square of A. So this is how we would prove question number A. And then now I'm going to erase this. I hope you have a piece of paper so that you've written this answer that I have given you right now. And now we move on to question number B. So question number B, it says that we should prove that cos of 2b plus 1 divided by sine of 2b is equals to cot of b. So before us proving this, we should note that cot of b is equals to 1 divided by tan of b, which is equals to cos of b divided by sine of b. So we are going to try to show that this here is equals to this here. So this is going to be equals to, so as I can see here at the top, I have cos of b. So I'll try to have cos of b here. So I'm going to write cos of 2b as, I'm going to use this double angle identity so that this is going to be cos square of b minus 1 plus 1 divided by, at the bottom, I have to have sine of b. So I'm going to write this sine of 2b by using this double angle identity here, so that I have 2 sine of B times cos of B, and this is going to be equals to 2 cos square of B divided by 2 sine of B times cos of B. This 2 is going to cancel this 2, and this cos of B is going to cancel one of the cos of B's here, so that I get cos of B divided by sine of B. And we know that this is going to be cot of B. So now I'm going to erase what I've written here so that I can have some space to do the questions that follow. And question C says that we should prove that sine of D plus 45 degrees minus cos of D plus 45 degrees is equals to the square root of 2 times sine of D. So here I'm going to use this for sine of D plus 45 degrees. I'm going to use this compound angle identity here. So by using this compound angle identity, this is going to be equals to sine of D times cos of 45 degrees plus sine of 45 degrees times cos of D minus, and now for this one here, I'm going to use this second trigonometric identity here so that I get cos of D times cos of 45 degrees minus sine of D times sine of 45 degrees. And this is going to be equals to, I know that 45 degrees is a special angle, so I'm going to use my calculator in order for me to get cos of 45 degrees. So when I press my calculator for cos of 45 degrees, I get 1 divided by root 2 of sine of D plus, and then sine of 45 is 1 divided by root 2 also of cos of D minus 1 divided by root 2 of cos of D minus also 1 divided by root 2 times sine of D. Not 45 here. I made a mistake here. It's supposed to be D here. And this is going to be equals to 1 divided by root 2 times sine of D plus 1 divided by root 2 times cos of D minus 1 divided by root 2 times cos of D plus 1 divided by root 2 times sine of D. So this 1 divided by root 2 cos of D is going to cancel this one, and I'll be left with this part and this part here. And we know that 1 divided by root 2 plus 1 divided by root 2 is root 2. So this would be root 2 times sine of D. So left hand side will be equals to right hand side. So we have proved also number D. So here I'm going to erase what I've written here so that I can have some space to do the question number D. So question number D says that we should prove that sine of 3a plus cos of 3a is equals to this side here. So here what I'm going to do is I'm going to take the left hand side, of course. So it's sine of 3a plus cos of 3a. And I know that 3a is a plus 2a. So I'm going to say this is equals to sine of a plus 2a plus cos of a plus 2a. And this is going to be equals to sine of a. For sine of a plus 2a, I'm going to use this trigonometric identity, which is going to give me sine of a times cos of 2a plus sine of 2a times cos of a. And this one here, I'm going to use this trig identity, this compound angle identity, so that I get, this is going to be plus cos of a, which is cos of alpha, which is a, times cos of beta, which is 2a, minus sine of alpha, which is a, times sine of beta, which is 2a. And now I'm going to say that this is equals to sine of a. So sine of a here times, I'm going to change this cos of 2a to, I'm going to use this trig identity. in order for me to get 2 cos square of a minus 1. So here I'm going to have 2 cos square of a minus 1 plus, and I'm going to also change this one so that I get 2 sine of a times cos of a times cos of a, also this cos of a here, plus cos of a, and then I'm going to change this cos of 2a by using this trigonometric identity so that I get 1 minus 2 sine square of a minus sine of a times 2 times sine of a cos of a. So this is going to be equals to 2 cos square of a times sine of a minus sine of a plus 2 sine of a times cos square of a plus cos of a minus 2 sine square of a times cos of a minus, here not plus, minus 2 sine square of a cos of a, and this is going to be equals to, I have this part here that is the same as this part, so I'm going to have 4 sine of a cos square of a, so I've already used this 2, and then I have this minus sine of a plus cos of a, so I've used this 2, and then these 2 are the same, so I'm going to have minus 4 sine square of a cos of a, and now I'm going to erase this part here. So now what I'm going to do now is I'm going to group this part and this part, and I'm also going to group this one and this one so that I get cos of a plus 4 sine a cos square of a minus sine of a minus 4 sine square of a cos of a, and this is going to be equals to, here I'm going to factor out a cos of a, so cos of a times 1 plus 4 sine of a cos of a. I'm running out of space here, and then here I'm going to factor out a negative sine of a so that I get 1 minus 4 sine of a cos of a. Sorry for writing on top of these double angle identities here. I do not have any space. So now, as you can see now, what I have now here is, no, here I'm supposed to have, here it's supposed to be positive here, not negative. So as you can see now, what I have now, because this part is the same as this part, I can write it as sine, not sine. I can write it as cos of a minus sine of a multiplied by 1 plus 4 sine of a cos of a. So as you can see now here, this, our left hand side will be equals to our right hand side.